Hey everyone, Tim here from SnapAttack. Let's dig into this week's threat snapshot. So we're going to be focusing on two recent Windows threats. The first one is a privilege escalation vulnerability affecting the Windows Extensible Application Markup Language Diagnostics API. A little bit of a mouthful there, but what this is, so Windows has a couple of frameworks for developing applications more rapidly. And with this extensible application markup language, you can build, rich GUIs and interfaces, using these tools. And they have a diagnostics API, which allows you to, more rapidly debug those applications. So this API allows you to inject, again, a DLL or some other, code for monitoring purposes and debugging. But this lacks some, basic security checks. So imagine if there's a built-in Windows utility, again, Task Manager, Terminal, some others there that are say running in an elevated privilege. If you're in an unprivileged state and you inject your DLL into that, you're going to gain the privileges, the tokens of that higher level process. So pretty simple vulnerability in concept. We have content for this, and we'll talk through that a little bit more. I always like to go through the source. So this is the author who found the vulnerability. If you want to learn a little bit more about discovery, how it works, this one was actually found on, pure accident when doing some, binary diffing. But yeah, we have the vulnerability itself. There is, again, POC available for this, so you can, use this code to exploit this vulnerability. Let's actually check it out in SnapAttack. So we've got this threat here that is captured and is using this POC. We can already see that there's going to be some recommended detections here. So let's watch the video. For those familiar with that taskbar, we are on Windows 11. This was introduced in Windows 10, so it does go back a little bit. And we just have a regular terminal here. We're going to run the POC, and then we're going to launch Task Manager ourselves. So the key thing here, I'm going to pause just to explain, what that POC does is says, hey, anytime the tool that I want to debug is open, let me attach and inject this DLL in here. So that's what allowed us to get that system shell when Task Manager was open. So there is a little bit of manual intervention here, but again, the attacker is going to be hands-on keyboard at this point where they have access to the machine, probably at a lower privilege level, drop this exploit, and then they can escalate and continue on their operations. Why do we cover privilege escalations? Again, it's very easy to, take that higher level privilege and then move laterally to other systems, potentially gain sensitive information, dump credentials. So definitely something you want to watch out for. Very easy to spot this attack on the process graph. A couple of things stand out immediately to me. So Task Manager normally isn't spawning child processes. Task Manager spawning, an executable is also suspicious. We can see Task Manager is launched with a high integrity level, so that CMD is launched with a high integrity level. That's, again, another interesting piece. And again, just showing that there's no magic here. That CMD where we spawn the PM, that POC is in a medium integrity level. So this is indeed a privilege escalation attack. So that parent-child relationship is interesting, which again is a great detection and threat hunting opportunity. This is a Sigma community rule out there looking for, again, Task Manager with suspicious child processes. Another opportunity is looking for the DLL load. So like we said, the heart of this is actually loading and doing a DLL injection. So you could do a hunt query like this looking for Task Manager loading any DLLs. You can see and fine tune that to like which directories they're loading from. So if it's not loading from, say, System32 or the Windows directory, that could be indicative of something interesting. Honestly, Task Manager doesn't really load a lot of DLLs, especially on Windows 11. So you can see like this doesn't have a lot of false positives. So this works, pretty much out of the box. But again, something that may vary a little bit in your environment. And of course, again, we do try to emulate these threats where we can. So, we do have an attack script where you can, test this POC, start Task Manager, see if that is going to work in your environment. So lots of good content here. Moving on to the next threat. So this is a combination of a couple things. So the main threat, if you're familiar with the attack matrix and all of that, is DLL search order hijacking. probably worth a deeper dive sometime on what that is, but the short version is when you are, an executable is trying to load libraries, there is a search order where it's going to say search in its current directory, search in system, search in other folders to try and find it. This is, again, maybe somewhat of a legacy thing just to make sure that there's compatibility, especially as there's other versions of, DLLs and making sure the right one gets loaded. Obviously, if it's not being able to load a module, that's going to inhibit some of the functionality of the tool. So this is a feature built into Windows. This now pairs with the Windows SXS or side-by-side. That allows Windows to have both a 32-bit and a 64-bit version running. And again, that's for interoperability. So you can have 32-bit processes running on a 64-bit operating system and everything still kind of works smoothly. So some researchers were going through looking at, a lot of these Windows side-by-side tools, looking for DLLs that would be loaded, and they found several opportunities here where this works. So I'm going to reference again the original authors here, Security Joe's. They put this out January 1st, so this is still pretty recent. And it goes through, again, their research methodologies, a little bit more like what I said on search order hijacking. This is used by lots of threat actors, so maybe not necessarily the Windows side-by-side piece, but this has been used, in the wild quite a bit. And they were specifically looking at, dependencies in the side-by-side. You can see a lot more of the research here. Several of these opportunities here where, these applications loaded these resources out of the side-by-side folder. So there is an opportunity here. And again, as they say, there's probably a lot more additional vulnerable binaries and vulnerable DLLs that are here than what's listed. So we need to find some, more generic behavioral detections that are going to work against this sort of threat. So again, we did replicate this in our threat library. You can check this out here, have some detection opportunities, have attack scripts where we can test this. So that's all good. We can go ahead, we'll watch the video here and see what happens. So we are going to, let's see, tap ahead a little bit. So again, we're going to plant the DLL here on the machine, and then we're going to run one of those processes that is vulnerable to the search order hijacking. It's going to find that DLL in the current path, and when it launches, it's going to innocuously pop a calculator. Again, that could be something a little bit more malicious if you wanted to have it, backdooring your C2 or running other commands. So again, pretty simple in concept. Heading over to the process graph, we can kind of see that tree. So again, we ran this engine task executable that's vulnerable to the search order hijacking. It loads that DLL, so that we're going to see the run DLL 32 call here, which again is going to spawn calc. Notice this is all still in the medium integrity context. This isn't a privilege escalation. Why would I even use search order hijacking in the first place? Honestly, it's stealth. It's EDR evasion. It's detection evasion. Again, if I'm less familiar with Nginx or Engine Task or other tools on the machine, I might think this is normal operating behavior. Maybe not spawning calc, but seeing run DLL 32, and honestly, a lot of DLL search order hijacking. Again, if done really well, you're not going to even see that. It's going to load the DLL, and it can run the activity, run the threads, make direct API calls inside of that DLL, which will be running inside of this process. Doesn't even have to spawn child processes. So this is just, again, more of a quick and dirty POC here. But there is lots of opportunity to, again, evade detections this way. This is why attackers use this sort of thing. So it is critical to, again, find, detections that are more generic that work across this threat. So we do have two in the library that are validated, tested. This one is, again, looking at search order hijacking. You can see here this one in particular is focusing on that run DLL 32 that's going to be spawning. So that is an opportunity for process events. More likely, again, the best way to detect this sort of thing is with an actual image load or mod load event. Again, we are loading a DLL, a module library. So being able to see these here is going to be much more interesting, much more relevant. Specifically here we're looking at the system32, the syswow64, those side by side directories. But we can expand this to a more generic here to look at other DLL loading things. Again, just having the context of where these DLLs are coming from, or where the processes are coming from, is going to be the interesting piece here. And again, this would apply to other DLL search order hijacking techniques. So that's a wrap on our threat snapshot for this week. It is a weekly series. Like, subscribe, comment below the video, and we'll see you next time.